Hi, everybody. This is Kubernetes Working Group Device Management Meeting for February 17th. Let me display the agenda and get us going. Okay. So, Omer, looks like you have something here.
We can't hear you, Omer.
How about now?
Yes.
Yes.
Perfect. Okay, so should I just go ahead, or do we want to go over the points first? All right, I'll go ahead. Okay, so first, hi everyone. I'm Omer. I'm from the NVIDIA team, and today I want to present a problem that we came into with the DRA API, where it comes to declaring devices that are mutually exclusive with each other. And I want to present the problem and a couple of proposals that we have to solve that problem. So is it possible for me to share my screen, or can I use?
Yeah, let me give you, I'll give you co-host 1 sec.
Okay.
Okay, you should be able to share now.
Okay, let's see. Perfect. Okay, you can see my screen now, right?
Yes.
Amazing. Okay. So the use case that we have here at NVIDIA is that we have GPUs that we want users to consume using DRA. And a use case of a usage of those GPUs is that we allow users to share GPUs across pods or across containers. And we have a few, let's call them partitioning schemes that we support, but those partitioning schemes are mutually exclusive with each other. So let's say we have partitioned a device in a specific way due to a resource claim. It will be an invalid allocation to allocate another claim which attempts to partition the device in a different way, which will cause, with the current API, what will happen is that we don't have the ability to declare that mutual exclusiveness at the resource slice level. So what will happen is that the driver, the DRA driver itself, would fail the resource preparation due to those device types being incompatible with each other.
Omer,
That is the
can I ask you a question? So
yeah.
just to step back a little bit, we have the ability to share claims, and through consumable capacity, we have the ability for claims to share devices, but there's no way to share devices. The way you stated that didn't quite make sense to me. If you already had a claim that had
Yeah.
partitioned it, then the only way to get access to you're saying the underlying device has been partitioned.
Yes.
So
Yes.
in
Exactly.
our partitionable devices, all the other devices associated with that are partitions should have been removed from eligibility. So I'm not. Anyway, maybe you'll get there when you finish it, but I'm not quite following yet.
Maybe,
Yeah.
I don't want to say too much here, but maybe as a quick thought model, probably what we want to do here could also be done by, frequently updating resource slices. which is something
Yeah.
we don't want to do. It's really about kind of mutually exclusive device groups. And then, of course, Kevin has his way of explaining it, but maybe we should also just
Okay,
let
I'll let you-
I'm also waiting for the example that shows why partitionable devices doesn't solve this problem.
Yeah,
Because
okay,
that
I
is
can-
what we have for mutual exclusive access to something. And it doesn't have to be actual partitions. One set of devices could be for exclusive mode. Another set of devices could be the time slice device, and yet another set of devices could be for the in hardware partition mode. And then you would have one counter that basically gets decremented to 1 whenever one of them gets allocated.
Yeah.
Yeah, but
Let me jump in here maybe because what you just said, actually, maybe I misunderstood the way you worded it, but what you just said isn't actually possible with the existing partitionable devices model. Because the way I like to think about it in terms of concrete examples is imagine you've got a GPU and you want to split it up into a bunch of MIG devices. That's one partitioning scheme. You've got the same GPU, you want to split up into some other different partitioning scheme. Let's not even give it a name, but it's a different partitioning scheme from which you can divide this GPU up into a set of different devices. The problem is that once you allocate one MIG device from this GPU, any future ones need to also be MIG devices. They can't be from this other bucket.
I think I see where the partitionable devices feature falls short of what you want to achieve, but it would be good to continue and see and get that called out.
Yes,
Yeah.
like
So
I think
that's the
that
problem. That's the problem we're
I-
trying to solve, and I think that's what Omer's about to propose is a way to
Yeah.
extend the existing partitionable devices feature to allow this kind of mutual exclusivity. Like sure you can use that terminology, but the idea is that once you've latched onto a GPU with a specific partitioning scheme, you have to keep allocating out of that partitioning scheme for that GPU until they've all been freed back, and then you can potentially switch to a different partitioning scheme and allocate out of that bucket.
Yeah,
we
exactly.
should let Omar continue to present. I just want to also quickly make the remark logically, like almost like mathematically, I have convinced myself that what we want to model here cannot be modeled with counters that can only be decremented. So like while so far in this meeting, we haven't presented that example clearly yet that shows this in a really, say, intuitive way, we're very sure that the existing mechanisms lack the ability to model what needs to be modeled. And now I'm shutting up.
Okay, cool. Thank you. Sorry, please
Awesome.
continue.
Yeah, thanks for the clarification, guys. So yeah, as Kevin and JP said, the issue that we present here and that we want to solve is that devices from two different, there is no way in the current API to prevent allocation of two devices of different partitioning schemes. Let's say even with the partitionable devices API. So if we look at the GPU example, so as Kevin mentioned, if we have a MIG device that consumes a counter set, and we have a different device which is partitioned in a different way. The MIG device is partitioned in the MIG slicing partitioning scheme, and the let's call it MPS device is partitioned in the MPS sharing scheme. Both of them consume the counters in a different way. They maybe consume them with different amounts, but there is no way to enforce that once a MIG device is allocated, MPS devices cannot be allocated until all MIG devices were deallocated and vice versa. This is the problem that we want to present here. And as I said, this the side effect of this is that the scheduler is not aware of those constraints. It will attempt to bind pods to potentially it will bind pods in a potentially dead on arrival manner. So pods will be bound and the container start will fail. because the DRA driver cannot prepare the resources properly. So that's the problem. I have gone over that. And the goal of our proposals, we have two so far, is to allow for a declarative way for drivers to specify which devices can be allocated alongside other devices. We want the scheduler to be aware of those constraints in order to support any scheduling features it has, including preemption and eviction. This is why we initially thought of an alternative to dynamically modify resource slices to hide and represent devices according to a currently allocated partitioning scheme. But we noticed that this will affect preemption and eviction because the scheduler will never know in a resource contention scenario, it will never know that there can be resources allocated to, let's say, higher priority pods if a specific device was evicted. We wanted that mechanism to be generic, didn't want it to be specific for a specific hardware type. And we wanted everything to be backwards compatible. So all features or all additions we propose here should be opt-in. And if not used, scheduler and drivers can behave as they do today. Okay, so I want to start. Any questions so far, by the way, before I get to the proposals? Amazing. Okay, so the first proposal we have is that we can add a attributes-based exclusion, which means that a device will have a new field called excludes devices. The naming is open for ideas. And what will happen is that we can append, let's say, exclusion rules by attributes to specify which devices will be blocked from allocation or are blocking the allocation of this specific device. This also shows that you can define more complex, let's say, expressions. And I'll go to an example I think would be easier. Okay. Let's look at the first example. So let's say there is a device which allocates the entire underlying device, and it will exclude any other device that is bound to that same physical device. So no other device sharing / fractions at the partitionable devices level can consume the underlying device. The second example is, let's say we have a device that is partitioned in a specific mode. Let's call it hardware partitioned mode. And that hardware partition mode is exclusive, is mutually exclusive with the exclusive mode and with any time sliced modes. Meaning that if we only had 3 possible partitioning schemes, the hardware partitioned would be mutually exclusive to a device. Once it's allocated, no other partitioning scheme can be applied to that device. And the third example for a time sliced device, you can see that it's exclusive with it's mutually exclusive with a full allocation or an exclusive allocation, mutually exclusive with hardware partitioned devices, but it is compatible with other time sliced partitioning schemes that the driver supports. Any question about the first proposal? John, do you have your hand up?
Yeah. I don't think the first proposal is going to fly because it requires comparing. It basically creates an n squared effect on at scheduling time on the number of devices. So you have to compare every device to every other device every time you scheduled to see if it can if it's compatible with what's already scheduled. So I'm curious to see proposal 2. I can think of a few other. Well, anyway, we'll continue on. But yeah, this is great. Like, well, let's continue on to proposal 2. But I'm thinking this one probably is going to be too compute intensive.
I also would like to call out that our initial API reviewer, Tim Hawkin, hated this kind of nested pseudo language in YAML. So this will face criticism from API reviewers because you basically don't know how deeply nested this and or by attribute leaves in your tree can be, and it's it's a problem that would need to be overcome, or some obstacle or some objections that you would face if you were to push forward with this proposal. But let's see what proposal 2 is.
Okay, thank you. Okay, now let's move to the second proposal. This proposes a new compatibility groups field within the device consumes counter struct. In this example, we can see that a specific let's say partition device consumes a counter set as it does today, but it also specifies a compatibility group, meaning that it is compatible with other devices that specify this MIG compatibility group. And for devices that are compatible with multiple compatibility groups, those devices would specify multiple compatibility groups, and other devices must match any of those compatibility groups. So meaning we can, in this proposal, we can control not only mutual exclusivity, but we can also control, let's say, groupings of device types, let's call it, on a physical device. This is actually also possible with the attribute-based exclusivity, but it's much more verbose. And with regards to semantics for both proposals, DRA drivers are responsible for declaring at the device level with which devices that device is compatible with, or which devices it excludes. Those rules should be applied to all resource claims and slices within a device class to prevent any, let's say, mutual exclusiveness across different device types. And as you said, the scheduler should also be aware of those constraints when attempting to schedule pods and preempt pods. Yes, I think John, you had your hand up first.
Yeah. So in this case, your compatibility group is on the consumes counters. So what you're saying is that any
device that consumes this counter will also have this constraint.
But
I can maybe add a little bit of touch a bit of light to this. So like we typically, like in many cases, in our case in NVIDIA certainly, like we model a physical device with one counter set. And so now the moment someone wants to consume from that counter set, now we basically want to add a new constraint. And that constraint would be that the intersections of all compatibility groups across all allocations from that counter set must be non-empty. So also there's that thinking that that's probably state that's in the schedule already, right? The counter set and how much is already consumed from it.
Yeah.
So hopefully, ideally, it's not like terrible in terms of like additional like business logic and like resource footprint.
Right. You could basically, in that same structure, you can tag and say this counter set is now tainted this color. I mean, that's the way I think about it.
Right.
And then,
Yeah.
or these colors. And then if it's the first one, it has two. And then the second one comes along, it's got to be one of those two. And then the third, and if it's only one, then the third one that comes along has to be that same one, because now it's like we're continuing it.
Right. Yeah. And it kind of, just from a primitive's point of view, it seemed right to attach that to the counter set and not to the device. So if we ever have, I don't know, the use case where a device consumes from multiple counter sets, I don't know what that means, but it still seems like the right thing to kind of associate that concept of a like compatibility group with the counter set itself.
I also expect that it's kind of closer to where we would implement it. To me, this is conceptually like a counter with a value of 1, but it only gets decremented once by the first device in a certain group that gets allocated. And then
yes, Patrick.
When it remains 0, no other group can decrement that counter unless and when the final user in that group that gets deallocated releases that counter of 1. I see that we need the groups for that, because we need to know when to decrement logically, and so this proposal kind of makes sense to me. Just one thing stood out in the explanation. We don't have a concept of devices being in device classes. So this description probably means something more like exclusive within the devices in a resource slice pool. That is what the scheduler sees. It might just be a wording thing.
Yeah, that's what I meant. Okay. Sorry for the confusion.
So I want to just kind of time check here. We're 25 minutes in. This definitely looks more viable for all the reasons stated. I think it would be interesting to also write down what Patrick just said, just like without the groups, what if we just had different operations on like different ways to account for individual counters, like say, when you consume the counter, it can be, well, I guess it would have to be.
John, you have your train of thought is valuable. I was like, actually, I personally, like, I can say that I spent quite a bit of time like thinking, how could we do this using counter sets? Using, I don't know, crazy large numbers, and one set deducting, I don't know, one order of magnitude, another set, deducting a different order of magnitude, right? And I was trying to find ways, but it seems like really with the shared counters this doesn't work. And then what Patrick said, I think that sounds right in terms of implementation. The point is one would decrement by 1 and not for every allocation. That's the big difference, right?
Right.
It's a semaphore of size 1.
Yep. Yeah, and the other option that came to mind is Kevin's original proposal before we went to shared counters was a tree structure, right? And this starts to, you might be able to do this in a tree structure. We flattened it. If you added one level of tree, you might be able to do something, but it may be maybe more complicated than this, right? I'm just trying to like you said, you maybe already did this, just like you presented 2 options, there's probably 3 or 4 or 5 more. But like if you already disposed of those, it might be just good when you write the cap to put a paragraph saying, we thought of this, but we decided it was too hard because of blah, at least so that people don't keep asking the same question.
I'd love to hear about the other options, because I personally am not sure I have considered all of them, so it would be simply interesting. So John, maybe I'll reach out if you have a summary of those initial ideas or previous let's say the previous API proposals that could
the previous structure was like a tree structure. Well, Yeah, we can talk about those. I'm just hesitant because I'm after this week I'm on vacation for like 10 days, so it would have to be this week.
Okay.
Yeah.
No
I mean, we're not proposing this kept for 136, just to be
No,
clear. It
no,
would be,
Yeah.
we have time. Yeah.
so there's time.
I think John Hune was the next hand.
Cool, thanks. Yeah, so one thing that stuck out to me with both of these options is that the compatibility is defined on each individual device, which seems like it might kind of blow up the size of a particular resource slice if you have like a bunch of devices in one like group or that sort of thing. So if there's some way to match based on like just attributes or something that can be defined like once in a resource slice, I think that might be ideal versus having to duplicate something like for every single MIG device having the same thing. So just one
I agree.
other thing to look out for.
That was actually an addition to the first proposal that I showed. That's where we defined the exclusion terms at the resource slice level, and then we just added a reference to them. Because I noticed that the resource slice got very, very large very quick. So I think it applies here as well, I think.
Yeah, if I can comment on that specifically. So we have this proposal for mixins, which covers some of this kind of thing, but Morten and I have been talking more recently that like with a lot of these features that are coming in, like we think even mixins is what we're going to end up doing is exploding the different types of mixins. And so we wanted to toy with the idea of device shapes. This is something we talked about, Kevin and Patrick and Tim and I talked about ages ago, a kind of way to define what an individual, like say MIG partition looks like, and then just point to that once. Mixin was kind of a compromise because whatever, for some reason, I don't remember the details, but device shapes, there were issues with it. So we think there might be something like a device shape and mixins, probably both, but like that basically led us to kind of define the policy of how this device operates and then just list a whole bunch of them just with their unique attributes. That's what we are going for with mixins, but it kind of like grew. So we have a separate cap on mixins, and probably in the same maybe 137 timeframe, we can start to look at if there's more we can do there to kind of define those things.
Okay, I'll take a look at it. Thank you.
Ale?
Yeah, so this problem also becomes interesting when looking at KubeVirt workloads, because in KubeVirt there is an additional, with virtual machines you have additional vGPU slices, and running containers and VM with those slices, this is something that will be required for that to happen. So very interesting that this is brought up here. The quick comment I had was what was in line with what John was suggesting. Like if we can have an attribute, let's say parent device or something like that in the resource slice, which is standardized, everyone in the community knows that this represents a physical device. And then from that standard attribute, if the scheduler can figure out that these counter set consumptions are belonging to that attribute, then we can somehow model the invisible increment and decrement that Patrick was suggesting of the counter of this compatibility group through the combination of that parent attribute and the counter set. Is that an additional alternative here?
So I certainly hear that there's a lot of room for kind of, just compression, right? So let's not duplicate information where it's not necessary. Of course, I think things should still kind of be expressive when you read them, right? So the intent should be, I always like that when you read a resource slice and you kind of know what it does. It shouldn't be auto cryptic. Where in that kind of trade of what you propose falls in, I think we'll see.
I think Ale's point though is that do we need a way to indicate something's a physical device? So I hear this from the auto scaling folks too. They're like, okay, you've got all these super crazy partitioning things you can do, and we can predict what resource slice, but we also just want to, like, can we just count physical devices because this is hard? And so like we might want to think about, I think that's another like thing we should put in our 137 design frame is, are there use cases for that? And Alay, I think, yeah, like definitely being involved in this CAP discussion to make sure it meets KubeVirt needs, I think would be useful. So this is awesome. This sounds like really fun, interesting stuff for next cycle. I want to kind of cap it there unless there's other people with critical things, because we have other.
I just want to quickly say, we're looking for use cases. I mean, we have thought about some use cases, right? But then we're also interested in kind of finding use cases that we haven't thought about, and of course that's, I think, the most important type of feedback to get.
Yeah, so I'm wondering about, I mean, the reason I bring up tree is like in the multi-node topology use cases, there's a tree structure represented, and we can't quite capture all the things right now. So I don't know if this would relate to it or not. Probably not, but maybe. So there's a few different. We should set aside an extra hour, like, I don't know, to talk about different design options, or at least do it offline. And they may be 4 separate caps. I don't know, right? I just like there's a lot of interesting modeling things to do. And I don't know if I saw there's is Praveen here, because Praveen has potentially some other interesting things similarly in the native resource stuff. There's some restrictions on how things get shared and things like that, which might which may or may not play into this. So we'll have some fun conversations, I think. Anyway, I don't want to, let's go on to the next. We have a few more. Looks like Sebastian.
Yeah.
Thanks for the time.
Can you hear me?
Yes. Do you want to display anything, or want me to make
Yeah. Can I share like my screen and show the document?
You should be able to now.
1 second. There you go. Let me know if you see the proposal.
Yes, we can see it.
Okay. So the idea, I talked about this one a couple of weeks ago. I have some PTO and things like that. So I'm back on this one. And the idea here is to have a shared counters. That's the idea. So I was looking into the 2 features that we have today. So today we have like partitionable devices, and we have the consumable capacity, and see like what is missing, I will say, from our use case. I will explain first our use case. So in SRV, or even like scalable functions in the future and things like that, we need to support bandwidth allocation, not enforcement. Enforcement is done by the driver, and it's already working as part of the SRV operator, but in like scheduling point of view. And the thing is that consumable capacity is on devices. So on putting like bandwidth on the VF itself, it's not something that will help me, because like if the PF has 200 gigs, I can't put like 100 on any one of the VFs and use it as a consumable capacity, because I can have, of course, over provisioning and things like that. So that was the general issue. And with partitionable devices, my problem is it's static. So the allocation is on the resource slice and I can't use it. So my proposal here is to have a shared capacity that you can put under every one of the resource slices. So that was my general idea. How it's going to look like, if I go here, you will see you have like a shared capacity for the physical function. Let's say it's a max of 10 gig, and every device will be connected to a shared capacity. It can be more than one, of course. And this way, when the user make a request on the resource claim, it just requests the capacity, and it's going to be reduced from the shared capacity of in this case, the PF itself. That's the idea.
So this basically is in addition to shared counters, you'd have which are internal to the device and not visible to the user. You'd have shared capacity, which is exported to the user, and
no, I wouldn't say that it's exported to the user. It's just that the consumable capacity is not attached to any particular device. It's more like a global capacity that gets drawn down by different device allocations. So it's kind of a mixture of consumable capacity and counter set.
Exactly. And the idea is, my idea was to continue on using, like, from the resource claim template, was to continue to use the existing API, so capacity will remain here. And in case you have the same name of capacity both on the device and a resource, so it needs to allocate both. I write that one a bit more down in the document, but I try to catch any edge cases because I'm using the same capacity API in the resource claim template.
Yeah, we discussed that before with Lionel. Did you coordinate with him on this proposal?
I show him this one because, like, he was he is like working in Reddit now with us about DRA and all that stuff, and I would say Multus next version, things like that. But from their use case, like from, let's say, easy devices like Mac VLANs and things like that, that's why they put the consumable capacity, and that's what they needed. So the VFs was out of their scope when they start working on the capacity one.
No, I'm asking because he volunteered to write a cap, pretty much like you did, like you did here. If he hasn't mentioned it, perhaps remind him. It was meant for 136, and clearly hasn't happened. I don't think we have a tracking issue yet. But if he doesn't have time anymore and you want to continue, okay.
Yeah, so Lionel's here.
So yeah, I'm here. Sorry. Yeah, we synced a few weeks or months ago with Sebastian, so I'm aware of this work, and yeah, I was fully aligned with what Sebastian proposed here.
Okay,
so
cool.
So we just need an owner then, someone who creates a cap issue and starts thinking about writing a cap for this, because I think the idea makes sense. The usual problem, we need to specify the API, need to think of corner cases and all of that, but I don't see a reason why we shouldn't move forward with this.
Yeah, I'd like to see again some additional alternatives. Like one thing we've talked about, and this might be simpler. I kind of like what you have here, but like I think I'd like to at least see if the same use cases can be covered, and if you look at the use case coverage, like, because it could be more or less of different options and the complexity. So like some of the other options, like you could, for example, in the consumable capacity definition, there's a sharing policy definition for each type of resource. You could associate a container set, a counter set, an existing counter set, and with, and counter rather with a resource, right? So that the scheduler can then do the same accounting. I don't know if that's better or worse, right? But it would allow you to say, hey, it would do almost the same thing, but it would be connecting it it would connect it to an existing counter set, as opposed to.
But the counter set will be static, right? I can't say like 1 gig, 100 megs, and all of that. It would be
static on the PF, like, and then each individual consumable one would say, oh, when you're consuming 100 megs in the consumable capacity, yes, you're going to mark 100 megs off this consumable capacity of this device, but you're also going to take 100 from this counter.
Mm.
So right, so it's sort of like doing it only at the consumption side, not creating a new shared capacity, but using the existing counter set, but making the consumption of it done as a function, a one-to-one or some function of the consumable resource.
Mm-hmm.
So the connection point's different, right? Whereas what you're doing is you're saying, hey, create a separate entity and then use the same API to consume from that entity rather than from where it does now. And here we're saying, well, consume from where it does now and point to an existing entity. I don't know if that's better. It might be more confusing, right? But I at least want to see it written out, right? So it allows, the one little thing it allows you to do is like, you could make that a function, not a one-to-one connection, but I don't have any real use cases for making it a function. So
yeah. So with this one, like I will think with Lionel because he already did a cap and things like that. But the way going forward should be like open an issue on the enhancement repository and working on the cap. What should be like next step from your point of view?
Yeah. So start with an issue on the enhancements that says defines the problem you're trying to solve, like not the solution. So like, rather than saying shared counters proposal, sometimes our caps, our issues are like, do this, right? But I think this one's, something about consumable capacity and partitionable don't cover, all the cases or something like that, or dynamically, I don't know. You have to come up with a good.
I will find a good name.
And then we can describe the different alternatives. And this looks like a very viable one for sure.
Yeah, Leonard?
Yeah, I'm just wondering if we should add more use cases, because I think you mentioned only the SRV case and subdevices, subfunctions. Should we try to find more use cases in that case? I think Mike Zappa showed some demo a few weeks ago about InSig Network about something quite similar for IP addresses. So we use capacities to allocate IP addresses and to know if we are running out of IPs in the subnet. So maybe it can be covered using this feature.
That would be awesome. Yeah. I think there's again use cases when you get to the multi-node stuff too that might be interesting. So let's start with the issue. We'll start defining the use cases, and then we'll define a bunch of same as the last thing, right? It's like, what are the use cases? What are the ways to model it? And then we try and find the best one that
sounds good.
Doesn't make people's heads explode. So awesome. Thank you. Anything else on this one, or should we move to the next item? Okay, it is Francesco.
Hello. So the problem statement. Now, for all the device drivers or the DRA drivers I'm aware of, the only way to make them compatible, except the couple attributes we standardized, is for each pair of drivers has to chase each other and see, okay, which attributes do you implement, what makes sense to me for implement, so you can have alignment. And so the question is, should we have something like a staging area for attributes, like, okay, those are the things we are trying out, don't depend on them because you're risk, or so drivers can iterate over them and have a central place on which they can do this dance? Or does it make sense? I thought about why should not we do that, because creates more bookkeeping, creates a precedent on which, yes, I know this is provisional, but I'm going to depend anyway. But still, in my opinion, it could help. It could help because it creates a progression path and creates a single place instead of basically going trial and error when we try alignment. So this is the real question for this forum is, how do we handle the problem about driver attributes compatibility and the second question would be if this proposal of a staging area of sorts makes sense.
I think Alay's hand was first.
Yes, to me, having this staging area makes a lot of sense. I think coming from the KubeVirt perspective, the NUMA attribute is important because I think it's baked in one of the APIs. But then also it's important to see the long-term direction of whether accurately it reflects the right topology from the devices. So from those perspective, I think it will be very useful. And regarding the comment on additional bookkeeping and how to make this safe, I think with the downward API cap, we introduced a mechanism to have a feature, have a command line flag in the controlled by the plugin framework. So if we have a staging area, we can probably hide that staging area from production users through that command line flag approach. So in other words, it would be the realization of, yes, use this staging area, but only for development. And if you have advanced use cases, do it at your own risk.
Okay, so I mean, because as Francesco already pointed out, like I'm very like early in Kubernetes days, we had like alpha and beta annotations, and like right, they just in the name it was like alpha.kubernetes. It's like they just never go away because people depend on them, and then they've got existing manifests, and then you kind of have to keep them all around. So that if we made it something where by default nobody expected to publish those, and that you had to pass flags, and anybody using our framework, could access it, that might make it more palatable to me. But I'm really hesitant to do something where, I guess what the problem you're saying is that because these drivers are built by different vendors.
I can, sorry, no, I want to cut you, but I can give you examples. And the example is the usual suspect. We are playing with the NUMA ID and socket ID. And for example, DRA CPU calls it one way. DRA-NATE calls it another way. And the CRV, the DRA drivers calls it yet another way. So, I mean, this is silly and it's easy to solve. You file a couple pairs, but I think it's pretty clear where this is heading. I mean, because this model doesn't scale. So I'm not saying this is a good idea per se, but I think, okay, what's the progression path while we are discussing an attribute and consensus, for example, is growing, or along the way say, no, this is not yet abstraction. So because right now it seems to me that either community fully agrees, we are all convinced, which is a good attribute, which is fine, but there is a huge gray zone on which, okay, perhaps NUMA ID is good. Okay, how do we try it out and see alignment between drivers? So this is the actual problem I'm after. I mean, making 2 or 3 drivers cooperate and say, it looks like with gaps, it's a good idea, it's not, to iterate. And I'm fully sold that this registry has its own, or staging area has its own drawback. So the real problem is, how do we make the drivers talk to each other? What's the path here? Align, not talk. Align, share. Yeah. I mean, it's common attribute language. So
I think that, I don't know if others, I mean, I could, like I said, if it's not published by default, and so users don't see it unless they, specifically go in and enable experimental attributes command line flag on every one of their drivers, like I'm kind of okay with that. Like that becomes just like a debugging, almost like a development feature that we have. In that sense, they don't become, I don't know, how do we coordinate? We still have to coordinate the names, right? But are we going to say is the proposal that we have like somewhere in the Kubernetes project, these are experimental names? That starts to get me worried that I mean, I guess then it becomes like, alpha features, right? And they could go away. And as long as we're not making them visible in production environments, that's the main concern for me, I guess.
It's a very valid point, and I don't have a good answer. And actually, I don't want to push this idea because I see what the point you're making. So this is why it's mostly an open question. For the time being, we can just move forward with PRs, but this is going, which is, I think it's going to explode in complexity soon enough.
Yeah, yeah. I mean, I think Ali's point is pretty good that if everybody has to pass a special flag, I don't know. Does anybody else have opinions? I'm not hearing any from the usual suspects. So I guess not. All right. Well, oh, Marlo.
Sorry, I was low. I had to find the hand button. We could start thinking about things like some sort of bit mask for alignment that everyone follows, like we've talked about previously.
Yeah, that could go in there too.
But there's some complexity that some devices have, like the compute domains. I'm not sure how we do a mapping, but I'm sure we could figure it out if we just sit down. But it's more of a bits level alignment.
Yeah, I don't think everything has to have it, but just the physical.
So the mask approach only works with aligning CPU, and it only works with alignment of NUMA kind of approaches, right? Or am I missing something there?
The bit mask thing, what we talked about there was kind of invisible alignment. So we always try to align, and then rather than people having to specify, we just like try and get the best alignment across all the devices, and we do that by having everything publish an adjacency to CPU map. So the CPU is adjacent to itself. The GPU adjacency is via, I guess, the PCIe or the socket or something, the PCI switch or something, root. And same with the NIC. And so if they all publish that, rather than the user having to specify the individual ways to align, we just try to get the best alignment, and always, whether they ask for it or not. And then we would have some flag in there that says, like, some API field that says like require alignment, which means we don't schedule unless we can get alignment. That was what we talked about like a year ago, but we haven't
yeah, it's mostly just NUMA, to answer your question quickly.
Yeah, I think what the point that Francesco was raising was more about how do we get a common space for everyone in the community to look at an attribute and work on. I think regardless of the NUMA alignment problem, that is still, like, you could have attributes that don't that are not involved in the NUMA alignment pieces and still require such a coordination, right? So seems like same problems but kind of separate.
Right. Okay, well, I guess for this one, maybe Francesco, if you want to just create an issue and just say, hey, I'm proposing this experimental thing, and we would control it the way Ale suggests with the flag so that it's not visible in production environments, and then we can try and solicit comments from there. I'd be curious to hear what like Jordan or somebody from API Review thinks about this proposal as well.
Okay, I will. Thank you for the feedback.
Cool. Okay, we have 5 minutes left. We have 3 minutes. Zappa, is that enough time? You want to just raise it here and...
Yeah, I can quickly just talk about it, and then we can continue the conversation. I put the link to the Slack conversation. And just a high-level situation right now is that the current order of operations that most people hopefully know, once a pod is binded to a node, the kubelet goes through the whole process of where DRA does the prepare the resources, and then post after that is the run pod sandbox RPC where the network namespace is created. And part of the conversation was, should we create the network namespace prior, the prepare resources, or as Alay kind of suggested in the conversation, creating a new RPC that has knowledge of the pod network namespace post run pod sandbox? Because the situation now is that you have network devices created in the host network namespace that are set up with an IP address. In some cases, they have routes. And in some cases, you also have processes bind it in the root network namespaces on listening on all interfaces. So in a sense, you could backdoor all your traffic to anything in the root network namespace. And the proposal is kind of, should we create the network namespace before or after so we can configure the net devs in the pod network namespace rather than do it in the host network namespace? And I don't particularly care how it's implemented. I just was kind of curious of how people were approaching this. And Kevin already has his hands raised, so we have a minute and we can always take this to Slack.
Sure. Yeah, I guess the high level comment is, I know we put it where it currently is very consciously, and I remember network namespaces and all of this was part of the discussion. But I don't remember why we decided on it. But I remember that this was all part of the conversation. So I think we need to dig up those old conversations and rediscover what the reasoning was for putting it where it was before we make any decision about whether we should move it or not. I'm pretty sure Antonio was involved in that.
Yeah. And I think, because in a lot of the cases, it's just because it didn't exist and it was kind of, a bigger conversation to say, okay, how do we deal with this post network namespace creation or pre network namespace creation? But there's the conversation like from over 2.5 years ago, maybe, that I dug up, and it kind of like just had like 10 words associated with this. But I did want to bring it back up to say, how should we deal with this? Because that situation that I alluded to would be the case that I've seen nearly 90% of my security incidents was something similar to this. And I just want to, raise it up. And Alay has his hand raised too. So we may have to table this, move it to Slack, and propose it for the next meeting. I'll take an action item to try to dumpster dive that conversation or conversations and bring it to the next.
All right, Alay, quickly.
Yeah, really quickly. To me, changing the place of that call seems to be like a breaking of V1 API at the behavioral level. So I think that should be strongly considered in these discussions.
Yeah, I had a similar, like, I don't know what the unintended consequences are there, and that makes me very nervous. Like adding an extra optional API call, like that seems much safer.
Yep. And that was the discussion that we had in the Slack channel, which I thought was like a reasonable trade-off and actually a rather nice one, because there's the other conversation from the container runtime perspective that we could have, but I don't think it's relevant for here. So I do like what Alay suggested.
Okay, awesome. Well, thank you, Mike. Thank you, Alay. And let's bring that discussion to Slack. And thank you all. Interesting conversations today. Looks like we're going to have plenty of work for 137. All right. See y'all later.
Bye. Thanks.
Bye. Thanks, everyone.